Okay, I got it.
Hi, Tessie. Do your work.
Okay. Okay, for Tessia to recap, I'm just gonna show, I'm not gonna, okay, Tessia. Okay, starting C nucleophiles, you add the C where the ketone is, it makes an alcohol. Here's mechanism for that. This is the mechanism for H nucleophile, which does the same as C. This is N nucleophiles. The primary ones make imines, the secondary ones make N-amines. Okay, on to oxidation. Oxidation, the secondary alcohols can be made into ketones with PCC or Jones, or any of these things. Primary alcohols, PCC goes to aldehyde, primary with Jones goes to carboxylic acid. And then aldehydes can be reduced to carboxylic acid with Jones or KMNO4, and then a mild one can also make it a carboxylic acid. But they will not oxidize primary alcohols. Okay, and now here we are. Okay, yeah, so for reduction, NaBH4, yeah, it would reduce ketones, aldehydes, and then the nitriles, she said would become, it'd go from like R. Oh wait, hold on. Yeah. Nitrile. Okay, so that's a nitrile. This would become the nitrile would become an NH2 group. So this C is here.
Why is that the same as the imine? Is that not the same as the imine?
The imine one, you see how it it doesn't lose this CH3 group.
But the starting thing, like the imine looks the same as the nitrile.
No, because the nitrile, the C.
Oh, are you recording this?
Oh wait, yeah, I am recording it. Oh wait, you're right. I don't know why she wrote it this way then.
Can you send it to me too?
I'm recording it for you, Tessia.
Oh, yay! Bye, Michaela. I'm going back to my breakout room.
Oh, I wrote it wrong.
Hello there.
Perfect.
You can either stay here or you can go to breakout room with Tessia. We're going over the entirety of the unit.
What's Tessia doing?
Watching her lecture. What else would she be doing? Okay, nitrile is R. Ooh.
Can you open a second breakout room?
I can't do it when I'm in. Okay, hold on. I'll figure it out.
Wait, no, don't worry about it then. I'll just stay here.
Just mute us, right there.
So much.
And then it'll be like you're in your own breakout room.
Okay, yeah. So this is nitrile. This C is this here, and then it just reduces to an NH2.
Wow.
And then LiAlH4. can
How
reduce.
come I've like never seen a nitrile before? Have you
Yeah, I don't know.
guys?
I literally only saw it in discussion today.
Okay.
Aldehydes, ketones, amines, nitriles. I'm gonna put the different ones in a different color. It can also reduce esters, amides. Your message with thick, I like it. Carboxylic acids. Yeah, and then it would reduce all of this to primary alcohol.
Is that detected?
Oh wait, not all of them. Ketone would not be. Okay, disregard that. It would
Someone
be.
left a note in the corner.
Yeah, I saw it. I said I appreciate. Okay. Yeah. So let's
Wait,
look
but
at
it does
one
reduce
example.
all of them in primary except ketones, right?
Yeah, except for ketone, I think it would reduce everything to a primary alcohol. Okay, anyways, let's do an example. So if we have okay. Wait, let's put like an NO2 here for kicks. I don't even know if that's possible, but
Okay.
okay, so one pass is LiAlH4. And then because NaBH4 is mild, I think you don't have to separate it into two steps. I think you can just do NaBH4 H2O. But
Why does there have to be oh, never mind, huh? I was gonna ask why there has to be water.
tell me when you're ready to go over it.
Okay.
Okay. So LiAlH4 would pretty much reduce everything except the alkene. Or yeah.
It reduces
So,
the OCH3 too, right? To OH or no?
Hmm?
Does it also reduce the OCH3 at the
Yeah,
end to
because
OH?
that's an ester, so that would become, and then it turns the NO2 into an NH2.
I forgot about that.
Let me just make sure it does that.
Wait, you lost an OH,
Oh, I did.
I think.
Wait. Oh, wait, no, yeah, everything got
Is it-
reduced.
Wait, isn't there one here? Oh wait, you know, like here? Or no?
No, because that's just this whole group is becoming a
Oh,
primary
okay.
alcohol.
Okay.
Yeah, and then for NABH4, the ester would stay. The NO2 would not be reduced. This would turn into a primary alcohol. This would go. Wait, did I 1, 2, 3? Wait. Oh, I think I messed up the. Oops. Yeah. Does that make sense?
Yeah.
Okay, moving on. And then there's also hydrogenation, but that's just like if you have an aldehyde. Sorry. This would only reduce the alkene. But then if you have catalytic with like a benzene, it would reduce the benzene to a cyclohexane from module 1, remember? And then this would also become an alcohol. Oh wait, shoot, I missed it. Primary alcohol.
Cool.
Why
did he go? He went over a lot of things in this module.
Yeah, I forgot to do with oxidation. Where is that? Okay. For this, you can also have. No, this is turning aldehydes into carboxyl. Okay, here. The Swern oxidation does the same thing as PCC. So if he says Swern oxidation, it'll turn a primary alcohol into an aldehyde and a secondary alcohol into a ketone.
Is there any time where we would need to like choose one over the other?
No, they do the same thing.
Okay. Also, do we need to know what the like actual like chemical looks like? Like for Jones's chromic.
Yeah, like for Jones, it's like chromic acid. I think he did go over PCC. I think.
Yeah. But residue, is this one have one?
Oh,
That would have to
Swern
know.
is DMSO and triethylamine.
Oh, okay. Wait.
Yeah,
Okay.
like in one step is DMSO. It looks, he has it drawn out like this. Oops. But I don't know if that's different than DMSO or if it says oxyl chloride. So I think it's two things. So this is, yeah.
Okay.
And then PCC, I'm not exactly sure what the structure of
I
that
don't think we
is.
have to know that one though.
Yeah. I think he did say it. I'm just not sure where. He went over PCC and Jones like a lot of different times in different lectures. Oh, he said CrO3 pyridine HCl. Okay. Okay, can we move on?
Yeah.
Reductions, reductions, more reductions. Okay, moving on to, now we're doing reduction of the carbonyl group. So there's three different things for this. If you remember, you have Wolff-Kishner, you have Clemenson, or Clemson? Clemenson. And you have okay, so Wolff-Kishner, the reagents are H2NOH, KOH, heat, and then there might be like a solvent in there, like, or some other sort of one. Diethylene glycol, he said. Okay, and then Clemenson is ZnHG and HCl, and heat. This is concentrated HCl. The last one is so it's like acetyl formation except with sulfur. So you have a thioacetyl. You can use the NCl2 or H3O plus. Or BF3. So that would be your step 1. And then step 2 is H2 Ni. So the mechanism of step 1 you would probably have to know, but step 2, I don't think you have to know. And all of these do the same thing. They all reduce to an alkane. Wolff-Kishner is basic, highly basic. So you can't have, so this is like one where you can't have any positive charge. That's why you can expel an OH in the mechanism.
Okay.
Clemenson is highly acidic. He said we don't have to know the mechanism for it.
For like the highly acidic, that one you can like do Clemenson with everything that has a like basically anything that has a halide in it, right? Because those would be base sensitive.
I mean, we haven't like, oh wait, you mean halide like,
Like if it has like a CL on it.
oh, got you.
That's because that's what Emily was saying in the GSS today.
She was saying what?
She was saying like to decide whether you should use Clemenson or Wolff-Kishner. Like you can use Clemenson with like basically anything that has a halide in it because it's base sensitive, and then you can use Wolff-Kishner for things that have like alkene and other acid sensitive things.
Yeah.
Acid sensitive acetals, you can use Wolff-Kishner for those.
It's just you have to be careful. I mean, we haven't really done like ester and like carboxylic acid stuff yet, but I think that those can be hydrolyzed in either basic or acidic conditions. So like if you have a carboxylic acid or any of its derivatives, like if you have a carboxylic acid and amide and ester in your molecule, then the best thing to do would be to use the thioacetyl formation, because this one is mildly acidic, right? Because it won't, because in extremely basic or highly acidic conditions, like that, if you want to keep that group is going to go away. So I think he'll go more into that next week with like the carboxylic acid derivatives, but like basically anything that's like, so say this here. Wait, can I go to another page?
Yeah.
Okay. So say you had a molecule and you wanted to reduce, oops. And so if this group like was like any, so it could be an OH, it could be an NH2, because that's an amide. It could be an ester. I'm forgetting if there's any other derivatives. Like an acid halide, I would feel. Then this group will not be conserved in highly acidic for basic conditions. So if you want to go from this to like then I think your best bet would be the thioacetyl.
Like, but for the for the CL one, because like one of her, you just did the problems, right? For Emily's thing. Because for number
Yeah.
9,
Which one?
number 9, use Clemenson.
Oh, I see what you mean. Because that one, the CL, like, okay, so let me draw that. So hers was, it was somewhat like this, right?
Yeah.
The CL, like, isn't attached. It's not an acid halide. Like, there's no
Oh, okay,
here.
okay. Got you.
So for this, you can use Clemenson.
Okay.
I'm not sure about if you could use Wolff-Kishner with it.
She said no.
She said no. Okay.
Yeah.
Because the CL is
yeah.
acidic. Got you. Yeah, I feel like because it's a leaving group, it would be affected. Hopefully you'll go more over like which ones to use.
Yeah. I mean, are you going to the office hours tomorrow?
Yeah. So maybe I can ask that too. Let me write that down. When to use Clemenson. Wolff-Kishner. And I'm gonna have to figure out like what questions matter the most to me.
I mean, you'll probably get a chance to ask a lot of questions. It's so weird because like there were so many people who went to like MS's office hours and like only like 10 people go to.
Oh really? Okay, that's good. Then
Yeah.
I'll have more chance.
Yeah.
Okay. I think the last thing.
The wedding one.
Oh, I haven't watched that video yet.
Oh.
But that let me see if I can remember. You have to form it literally you just go wait, hold on.
Mechanism is really nice.
Okay, first let's do the lecture before that. So there's diol oxid. I should have done this with the oxidations. Oh well. Where if you have and you can use IO4. I think it's also written as HIO4. And it just cleaves this bond.
Is that also just O3?
I think O3 is for alkenes. This is specifically for like.
Gotcha.
And then to form this, like the formation of this would be OSO4. He said we did this in Orgo 1, but we did not.
Yeah. I think our class did.
Oh, okay. Yeah, and then ozonolysis is like the other thing. And you have to use the the Me2 one to get aldehydes. If you use H2O2, it would produce carboxylic acid. So
Okay.
oh, I did it again. Yeah. And then we were gonna ask about the like Diels Alder thing he did, because it kind of didn't really make sense with the, so I'm just gonna skip over that for now.
Okay.
And then for formation of ketone aldehyde, he also had hydration of alkynes for module 1. So I guess just like knowing this would make ketone. This would make aldehyde.
Oh yeah. Wait, that's from module 1.
Yeah, but he had it in his video. And then the last thing is the pinnacle. Oops. So if you have bro, this should be my GSS recording video. Take me. This is my debut. Okay, yeah, and then this aldehyde, because it protonates. So the mechanism for this is it would protonate. I'm just gonna write it as H+. It's from the H2SO4. This leaves makes a carbocation. There's a hydride shift, and when the hydride shifts, this comes down. Oh wait, I forgot a methyl. Wait, no, I didn't. Did I? Hold on. Okay, yeah, there's an extra. Yeah, so I guess it happens there because that's the more stable, the tertiary position. Wait a minute. How did I? Okay, there's no. Yeah, this is a primary position.
But it only works on primary.
Yeah.
Okay.
And then the HSO4 minus comes in. I think someone, I forget if it was the discussion leader or him, said like you can have HSO4 minus in the H2SO4 acidic conditions. Oh my gosh, I did the asymmetrical one. No wonder I was so confused. A symmetrical one would just, it would do a methyl shift instead, I think. So like if you had it'd be like that. So this would be a methyl shift. Would come down. This would leave, did I leave it? Yeah. Yeah. I think in his thing he wrote A minus, like he used HA. But I think you can just do it this way. Oh shoot, I did it wrong. This leaves first. Let me just redraw these two steps. So this leaves carbocation. Now this comes down, migrates. Sorry about that. Okay, I think that's everything.
Wait. Oh, never mind. Thank you, Sir Teacher Navasan.
You're welcome.
We should use
Oh,
this
I'm like out of breath.
use this as your